Leak valves. What are they? How are they used? And why you want them for VACGEN? If you want to control the flow of gas into a system, you need some of these. Let's dive in and see how they work. In ultra-high vacuum systems, controlling even the smallest quantities of gas can be critical. Experiments in surface science, deposition, and mass spectrometry all require the introduction of extremely small and precisely controlled gas flows. Achievement of this level of control requires a specialized component, the all-metal leak valve. In this video, we'll explain what a leak valve is, how leak valves work, and where they're used in UHV systems. And then we'll take a closer look at the LVM and MD95 series of leak valves from VACGEN. A leak valve is a precision mechanical valve designed to introduce and control extremely small quantities of gas into a vacuum system. Unlike standard valves, which are designed for larger flow rates and rapid opening or closing, leak valves are designed for fine incremental flow control. A leak valve allows the operators of a vacuum system to introduce gas into the chamber at a controlled and precise rate. This controlled gas introduction can be used for, among many other things, calibration or inert gases, reactive gases for surface processes, controlled atmosphere experiments, or for general pressure regulation within a chamber. Leak valves are an essential component in many advanced research and industrial vacuum systems. At a high level, leak valves work by deforming a disc to create an incredibly fine gap within the valve body, through which the molecules of gas can flow. This is generally either a sealing pad or a deformable disc. The valves offer excellent compatibility and mounting choices through the use of conflat CF flanges. The LVM and MD95 series of valves offered by VACGEN are similar in concept, but they do have a few key differences. The LVM series is the most precise valve offering from VACGEN, being controlled by a precision hand wheel and offering excellent E-control between 10 to the minus 3 and 10 to the minus 11 millibar liters per second. The valve is made of 304 stainless steel, and it uses a Mallory 328 sealing pad. The sealing pad acts as the leaking seal. Due to the repeatable deformation of the pad when the valve is opened, after initial calibration run, this provides an incredibly repeatable flow of gas into the chamber. A key advantage of the LVM series, as opposed to other valves on the market, is the lack of a sapphire seat. This increases the long-term reliability of the valve by removing the risk of sudden failure and the uncontrolled flow of gas into the system that could be caused by the breaking of the sapphire crystal structure. In addition, the LVM offers a good level of flexibility when building up a system, being offered in two sizes of fully rotatable CF flanges, either DN19 or DN34. The MD95 series, offered by VACGEN, is a leak valve that has a few key benefits. These include being significantly smaller and more compact, and having a greater resistance to hot and corrosive gases than the LVM series, while utilising a slightly coarser method of operation. The components used in UHV systems must meet strict requirements for cleanliness, material compatibility, and stability. VACGEN's leak valves are constructed entirely from UHV-compatible materials. In both offerings, the bodies are 304L stainless steel. In the LVM, it uses a Mallory 328 sealing pad, or a nickel sealing disc in the MD95. In standard use, copper gaskets on the CF flanges ensure a leak-tight seal, but in environments demanded low magnetic materials, we offer silver-plated gaskets as well. This avoids any compatibility issues with elastomers and gas choices, ensuring that when fully closed, these have leak rates of 10 to the minus 12 millibar liters per second, offering true UHV performance. Both valves are very bakeable. The LVM series can be baked at 250 degrees Celsius while closed, or up to 450 degrees when open and under vacuum. The MD95 can be baked at up to 300 degrees C, allowing surface contaminants to be removed during the vacuum system preparation. Ultra-high vacuum leak valves are used in a wide range of scientific and industrial applications where precise gas dosing is required. In surface physics and chemistry experiments, such as XPS, STM, and sputter profiling, researchers often introduce gases, including helium, into the vacuum system to be used for, among other uses, ion beams. Leak valves allow for the controlled dosing of these gases while maintaining ultra-high vacuum conditions within the system. For thin film deposition and processes such as molecular beam epitaxy, reactive sputtering, and atomic layer deposition, all require extremely stable and precise gas flow rates. Leak valves provide the control and repeatability that is necessary to regulate these environments. For mass spectrometry and residual gas analysis, leak valves are frequently used to introduce calibration gases or test samples into mass spectrometers and residual gas analyzers. Because the flow rate is stable and repeatable, operators can precisely control chamber pressure during measurement. Leak valves can also be used to generate controlled pressure rises within a system to test or calibrate vacuum gauges and other analytical equipment. Leak valves from VACGEN are incredibly reliable, offering years of performance to customers worldwide. To help keep the valves working correctly, we do offer service kits for both types of valves that include new seals, pads, and diaphragms. We also offer a robust after-sales and warranty service. The LVM and MD95 series of ultra-high vacuum leak valves are engineered to deliver precise, stable gas control in the most demanding of UHV environments. For researchers and engineers working at the cutting edge of technology, reliable gas control is essential. To learn more about our leak valves and other vacuum components from VACGEN, visit our website or contact our sales team today.